Hi, I am Arezoo Hatefi, a PhD student from Computing Science Department of Umeå University, and I want to present our paper with title ADCluster, Adaptive Deep Clustering for Unsupervised Learning from Unlabeled Documents. So text clustering aims at some group semantically similar text without relying on human annotation. And there are so many traditional clustering approaches that could be grouped into density-based, hierarchical, centroid, and partition-based clustering. And these algorithms are like general purpose, and they could be applied on any sets of n-dimensional data points, so they are not like specifically for the text data. And two of the most popular algorithms in this category are k-means and HDBSCAN. But with the great success of deep learning in the recent years, there have been so many efforts to use deep learning for text clustering and also like clustering in general as well. And since clustering is an unsupervised task and like we don't have gold labels for the data set, many of these work have tried to use autoencoders for unsupervised representation learning for like doing clustering. And also with the great success of pre-trained language models in the recent years, there have been also some work to use these PLMs for clustering, and these work usually just use these PLMs for making document representations, and then they apply the clustering algorithm on these representations. But these are like representations from general domains, and they are not optimal for the target domain. So we need to adapt them to the clustering task. For example, Huang et al. Tried to do this adaptation by simultaneously fine-tuning the language model with clustering loss and also masked language modeling loss. But because there is a discrepancy between these two training objectives, this approach is not also very optimal for adapting the representation to the clustering task at hand. And on the left side of the slide, you see our proposed model, ADCluster, in comparison to the previous work that used language models for clustering. And as you see, we have an adapting iteration in our proposed model, which helps the language model to adapt to the clustering task and to generate clustering-friendly document representations. So this is the architecture of our proposed ADCluster. And as you see, it has two parts, one clustering part and one classification part. The clustering task and classification task iteratively promote each other, leading to the significant performance improvement. So in the beginning of each training iteration, we make document representations by applying an average pooling over the last layer of the language model. Then we do dimension reduction, and eventually we apply the clustering algorithm for example, k-means on these representations to predict pseudo-labels for the unlabeled data. And then we use this pseudo-label data set to fine-tune the the classifier and the language model with cross-entropy loss between the output of the classifier and the pseudo-labels generated by the clustering algorithm. We repeat this iterative process until the model converges, and we consider it as a converged model when the change in assignment is less than a threshold. So for example, in each iteration, we compare the clustering result with the clustering result of the previous iteration, and if the percentage of the data that has changed its cluster is less than a threshold, then we stop training. And also I should mention that this MLP component becomes irrelevant from one iteration to the next one, because like clustering labels are not fixed from one iteration to another one. And I mean, they are not corresponding to each other. So we need to reinitialize this MLP from scratch in each iteration. And also to prevent the bias from imbalanced clusters, we use a uniform sampler to make the training batches from pseudo-labeled data for training the classifier. We compared our proposed model with some state-of-the-art and baseline models for 3 datasets: Xuan-Son dataset, age news, and fake news. And as you see in the table, for Xuan-Son and also fake news, our proposed model outperformed the baselines, and the result are the clustering accuracy. But for the age news, the performance of our model is slightly less than the HDB scan accuracy. And if you look at this table, you see that the documents in age news dataset are shorter than the documents in the other 2 datasets, and the average number of sentences per document in age news is 1.45. And so we hypothesize that because the documents here are shorter, they don't provide the language model with enough context, so the language model cannot generate very well contextual representations for the documents. And also I should say that we implemented 2 versions of our model, the ADCluster final, the one that I explained in the previous slide, and also centroid ADCluster. In this version, we remove the MLP part of the classifier, and instead we compute the cosine similarity between document representations and the cluster centroid. And in this case, we don't need to reinitialize that MLP layer in each iteration. And this picture also shows the clustering result for the Xuan-Son dataset over epochs, several epochs, and it shows the inner adaptation capability of our model. So in the first epoch, as you see, the clusters are not very distinct, and we just have a point cloud. But as the training goes on, the cluster become more distinct, and that's because the language model adapts to the clustering task and generates more clustering friendly representations. We did some ablation studies to investigate the effect of different parts of the model. We replaced the language model, the BERT language model that we used in the original version of our model, with Roberta, Espert, and BART, which are more recent and more modern language models. And as you see, for all data sets, the accuracy increases by using these language models. We also implemented a non-iterative version of our model. So we just have one iteration in this implementation. We used UMAP dimension reduction instead of PCA, and also we used random sampler instead of the uniform sampler that I explained before. And in all of these cases, the accuracy drops. So it shows that the design choices that we made when we were designing this model, all of them are contributing to the final performance of the model. And we also tested our model for data stream. So for example, we have like an initial data in the first step. We train a clustering model for that. And then a stream of data comes into the system that needs to be clustered. So for the new data, the previous model may not work properly because we may have distribution shift in the new data. That could be in the form of emerging and disappearing topics in the new data compared to the old data, or the focus of some of the topics that we had previously in the old data could change in the new data. So the model needs to adapt itself to the new data to be able to cluster that. And in this work, we try to address the within topic distribution shift. So the number of cluster remains the same over the stream, and just focus of some of the topics may change. And to adapt the ADCluster to the data stream, we continue training the model for the new data. So for making the data stream for each data set, we randomly divide the data set into 5 chunks and we feed them to the model sequentially. We tested 3 policies for adapting the classifier to the new data, which I show here. So in the first step, we have initial data. We train the clustering model for that. And then in step 1, we get a new chunk of data. In accumulative policy, we add new data to the old data we had, and we continue training the clustering model with this data. In the non-accumulative policy, we just continue training the model for new data. And we have a third policy, which is training from scratch. And we could use either accumulative or non-iterative, accumulative or non-accumulative policies for training the clustering model from scratch. We compared the performance of ADCluster for clustering data stream with 2 baseline models, word-to-vec plus k-means and BERT plus k-means. These are completely static. So for each chunk of the data, we just generate document representations with word-to-vec or BERT, and then we apply the k-means on these representations. And as you see, for the 3 data sets, in most cases, ADCluster outperforms these static baselines. And also, in most cases, it outperforms the ADCluster trained from scratch. So it shows that like our model has the capability to adapt to data stream as well. But there are some limitations in these experiments, and the most important one is that for making the data stream, we are dividing the data into chunks randomly. So there isn't any significant difference between the distribution, topic distribution in these chunks. And we would like in future to make data streams that more effectively model this distribution shift and repeat these experiments and see how our model performs in these situations, and then accordingly like adapt our model and change it a little bit. And also usually text documents, especially news articles, which are of more interest for our research, are accompanied by some other modalities such as images, videos, or audios. So we would like to extend our model to multimodal setting and test it for multimodal setting as well. These are some references, and thank you for listening to my presentation, and please don't hesitate to ask your questions and share your suggestions. Thank you.